So we talked about properties of functions, looking at domains, codomains and range. So I'm going to do just a couple of examples for you in this video, looking at calculating those, discussing them with you, and then letting you have a crack at a couple yourself. So here's 3 questions for you. I just want you to be able to figure out what is a suitable range and domain for each of those 3 functions. So what I want you to do is pause the video, have a crack at them, come back and see the solutions. So, solutions for each of these. If we look at the first function, f of x equals square root of x minus 2, what we have to do is remember what is meant by domain and what is meant by range. Remember, an easy way to think about it is the domain is the values you stick into the function, and the range is what do you get out of the function. So look at the actual function itself. Now it's a square root function, so instantly what you have to remember is that the square root of anything has to be greater than or equal to 0. You can't put a negative value in here in order to take a square root of it. So what we have to do is figure out at which point this becomes negative. So what we have to then say is x minus 2 always has to be greater than or equal to 0. So to solve that, what we say is that x has to be greater than or equal to 2. So that means that we can only include values where x is bigger than or equal to 2. And that's our domain for this function. That x has to be bigger than or equal to 2. What we then do is we look at the range. So that's the values that we get out of that. If we imagine we sketch this curve here, what we'll get is a curve that looks something along those lines, hopefully slightly better though, where it starts at 2 and works its way up. Now this height will never ever stop increasing. So what that means is the range of values I can get is anything above 0. So my range is going to be any positive real value including my 0. So that there is going to be the range of the function that I'm going to be looking at. So there you go, there's your domain, there's your range. Second function, what we have to look at is f of x equals x squared. So again, we want the domain and we want the range of this function here. Now, the good thing about this is that if we look at x squared, there is absolutely no limitation on that. We can put any value of x in there and we can get a solution out. So in this case, my domain is every single real number. So my domain for this case is r. My range, we have to figure out what that's going to be. Well, if you imagine sketching it, if you sketch x squared, that should be a standard function, you know. It looks like that. Touches at 0 here, but never goes below it. So my range for this function is going to be any real value in the positive direction, including 0. So any positive number or 0, they're the possible solutions that I can get. So there you go. That's my set of solutions for that one. The final question was f of x equals 1 over sine x, and I have to calculate the domain and the range for this function here. Now, going to give you a little bit of a hint. Anytime you get a function that's of this format, so something over a denominator that has some sort of dependence on x, focus on that, because you know that the denominator cannot equal 0. So what we want in this case is sine x cannot be equal to 0. Now if you think of the curve of sine x, so let's imagine we sketch sine of x here. It's a wave function that does that. Every time it hits these values here, it's equal to 0. We don't want those values included, but we have to figure out a way to express it because sine curve goes off to infinity and negative infinity. It continues on and on. Well, if you think about it, that's 0, pi, 2 pi, 3 pi, 4 pi. So what that means is for sine x not to be equal to 0, x cannot be equal to n pi, where n is any integer value here. So something times pi, so 3 pi, 4 pi, etc. It cannot be equal to that. However, we want it to be an integer value. So instead of just using a generic n, what we're going to use is we're going to say x cannot be equal to z pi, where z represents our integer set of whole numbers, because that will then stick to it being something that is of that. I know natural numbers falls into place in terms of integers, but you've got to remember that only includes 1 up. We want to include every possible value, so we don't just stick with n, we stick with z pi. So my domain is every single other value, so our R, take away anything that involves z times pi, so our integer value pi. Our range is then the values that we can possibly get. Well, think about the sign. Sign's maximum value is 1, its minimum value is -1. So f of x's highest value is 1, because it's 1 over 1. F of x's lowest value is -1. But if we had sine of x tending towards 0 here, so getting smaller and smaller and smaller, what that means is the top dominates the bottom. So I'd end up getting 1 over values smaller and smaller and smaller and smaller and smaller. So what that would mean is that the top would increase, the overall size would increase, and it would tend off to infinity. If I then took the sign values to be the negatives, this would then end up getting closer and closer to 1, but it would then go the opposite way as we approached 0. So what that would then mean is it would tend off to negative infinity in terms of that when sine approached 0. So what that then means is that the possible range of my functions is infinity to negative infinity, but it cannot include 0. So what that then means is my range is all the real values, but it cannot include 0. So there you go, that's the range of that function there. Some of these do require a bit of logical thought. Doing yourself a diagram does tend to help. I'd recommend doing that as much as possible. Just think about the function and the behaviour of it. If you've got fractions, focus on the denominator to begin with. If you've got square roots, look inside the square root and remember the fact that that always has to be bigger than or equal to 0. They're key properties of functions that you should be able to remember off the top of your head and be able to bring into play in a question like this.